Hello, hello, hello. Welcome everyone to this episode of the Julia Dispatch podcast. I am Chris Rackauckas.
And I'm Guillaume Dalle.
Yeah, and so today we got another co-host in here, so we're growing the crew, growing the team. Hopefully, be able to put out more content, right? Which means that I'm gonna have to do all like the cringy like YouTuber things, right? Say like, oh, like, subscribe, and send it out to everyone to grow the reach and everything, right? But we got a lot of good responses on the first episode that we did. That was the This Month in Julia episode, and so we are doing more in that series, right? Also, side note, that's also some of the easiest content to create because someone else, well, Stefan has already written out like all the content here. We're just going through it. So more of these are definitely coming our way. And today with Guillaume, I mean, a lot of people here probably already know Guillaume, right? Because he's joined us already on one of the episodes, right? So he's one of our experts in a lot of things Julia optimization and also differentiation interface, right? So he'll be able to give a perspective to kind of balance out and talk about other things that I might miss. So first of all, sad that we couldn't have Stefan here for this one because apparently it's been 2 years of the This Month in Julia world, right? That's a
Happy anniversary.
pretty big milestone. Yeah, happy anniversary to that. And so really nice to see that's gone on this long. And front matter. I wish that we had someone that knew something about JuliaCon Local Paris on the
Damn.
podcast to discuss a little bit about it. But
If only there was an organizer nearby.
if only,
Yes.
if only.
So JuliaCon Local Paris, perhaps you can open the website.
Yeah, let's.
So if you hit juliacon.org and then you see exactly, so you can click on Paris and then you see that JuliaCon this year is coming to Europe as well. So I'm one of the co-organizers of this event, and we decided that it wasn't fair that the US gets to have all the fun with the global conference in Pittsburgh, and we
Lots
thought
of
that it
US
would be
fun right
nice. And we thought that it would be nice, for people who can't make it to the US to have an event in Europe. So we had actually done a few events in France. Some of my colleagues had organized the so-called Julia and Optimization Days a few years ago, and we decided to take it to the next level. So we recruited a team of motivated people, and we said, okay, can we, get people enthusiastic enough so that they'll come to Paris? Because it's obviously a very painful experience, hanging out in the city of love, talking about Julia, this kind of thing. So yeah, this is the committee. As you see, we got mostly French people, but also a few people from abroad. Amanda, my co-chair, is working in Germany at the moment. And yeah, so this will be 2 days of talks, tutorials, poster sessions, and a hackathon at the very end. It will happen right in the center of Paris at Conservatoire National des Arts et Métiers, which is a beautiful building in an old neighborhood. So you'll be able to walk around after the talks, before the talks, during the talks if they're boring. And yeah, so I'm not exactly sure when this episode will air. Probably the call for contributions will be closed by then. If it's not, please submit your talks. I know that Chris already has submitted his. And
a few.
A few, yeah. What I'm pretty sure about, though, is that the tickets will still be up for grabs. So if you're seeing this and you haven't yet booked your tickets for JuliaCon Local Paris, get your spots. The spots are limited. And it would really mean the world to us if you could, even if you're not submitting something, if you could just come by and chat about Julia or chat about other programming stuff.
Yeah, and if you've been following this podcast or other things, Julia, and you've not really talked with the community very much, and you're in the European area, then this might be a good first Julia event to go to. It's a bit cheaper than JuliaCon, and it could be, for some people, it'll be pretty local. It'll be a smaller community, and you'll be able to chat with a lot of folks in a way that's, to get to know some people before you go to the big, scary one, right? So this might be a very good event to go to if you haven't done one before.
Yeah, and I can announce here, you'll be the first to hear it, that we already have 2 confirmed plenary speakers, which are very high caliber. There will be Laura Grigori, who's a professor at EPFL in Switzerland, who can talk about linear algebra, high-performance computing. And there will be Yvette Galabova, who's one of the lead developers of HISE, which is a high-performance linear programming solver. So she'll talk about, presumably, optimization and how to scale open-source software to meet industrial needs. And we're still looking for the third speaker, but there are some very famous names in the Julia community that are being floated at the moment, which I won't reveal.
Alrighty. It sounds like it's going to be a great time. Yeah, I already put in a few talks, so I'll be there.
There's a certain percentage of every JuliaCon that has to be Chris Rackauckas talks. I think there's a legally mandated like 3%. If we don't have 3% Chris, we're below the standard. So
Well, I noticed that some of the other workshops have not been announced yet for JuliaCon. So right now it just says like the first day of workshops is me giving a workshop for 3 hours and then me giving a workshop for 3 hours. So there's a little bit of that. But no, hopefully the other workshops should be announced soon and on the schedule and everything. So, but I'm a talker.
yeah, and if you're at a company or at a scientific institution who wants to sponsor JuliaCon in Paris, it would be really helpful because we're being very careful with the budget. But if we had a bit more sponsorships, we could allow more people to come and, I don't know, subsidize their tickets or their trips, make sure that people from underrepresented communities or minorities are there too at the event. So yeah, it's the goal is to make Julia and programming and scientific computing as accessible as possible to everyone. So if you can contribute, whether it is by sponsoring, by attending, by submitting, please put in the work and would be happy to have you.
Alrighty. Yeah. So I'll be super happy to be there. So okay, I think next things on the list then is some Julia releases. I think 11.12 beta. Or 1.12 beta, right? We haven't talked about any of the 1.12 releases before, but well, we've mentioned that they're coming, but I mean it's in the beta phase now, right? So if you are testing your packages with pre, you're already seeing that there's stuff out there. Now, I was just looking for some of the discussions I had with some of the compiler developers. I think that beta 2 is not, if your package isn't compiling on beta 2, that's not too worrisome, I would say, at this point. There are some things that have been identified, and so there's going to be, well, I think beta 3 might have even came out yesterday,
Yes.
right?
Yeah.
So there's some things that are going through. I mean, it's going through multiple release candidate phase, but Julia 1.12 is getting pretty close.
And let me point out, because I know there have been some discussions on Discourse about 1.12 breaking some workflows involving, for instance, package compiler and things like that. This is still a beta release, so the whole point of it is to smoke out the bugs, and it doesn't mean that it's gonna look like that in the production ready minor release that will come later. So by all means, try it out. The continuous integration on GitHub makes this very easy. You just add the item, to your workflow in YAML. You can say, okay, I want to test on the long-term support version. I want to test on the Julia 1 version, which is the stable one. And if you add pre, as Chris says, PRE, it means you want to test on the pre-release version, so beta, alpha, whatever's out there, or RC. And that means you can very, very easily figure out if your package is compatible or not, and if not, report it.
So I'm just gonna show a little piece here. Here you go, 1.0 or not 1.0. Latest release, LTS. So that's gonna be 1.10 for quite a while, and pre. So if you have pre set up, then boom, now it's showing you 1.12 beta. And again, a lot of my packages are not compiling on the 1.12 beta 2. Fingers crossed it's better on the 1.12 beta 3. Open up issues. What's really going on right now is this phase to really just test out is 1.12 ready to release. And there's a lot of compiler stuff that went into 1.12, so there's a lot to kind of be worked through.
One thing I'll say about testing on the pre-release is there's this package called jet.jl by Shuhei, which is absolutely amazing. It allows you to spot a lot of typos in your package, test for type inference issues, etc. But it's usually broken on the very cutting edge of Julia. And I've had a few issues on 1.12. So every time there's a new minor version, most of my packages use Jet for testing. And there's a bit of some rough edges to overcome. So if you're like me, if you're using Jet for testing, please, don't be discouraged and open issues and try to work that out, because it's a beautiful package and I'm sure it's very useful to us.
Yeah, I always put Jet and Enzyme in a separate test group, so that way, CI runs different tests for those, because Enzyme's another one where it'll take a little bit before it's updated for 1.12.
Yeah, the danger zone.
Yeah, Jet, Enzyme, JuliaChecker.jl, those all live in the danger zone.
Yeah, but you live in the danger zone, Chris.
Oh yeah, my entire life is
Your
my
middle
middle
name
name
is
is
Danger
Danger.
Zone.
Yeah. All right. So the next is okay. The API for compilers lowering has been reworked, paving the way for the experimental use of JuliaLowering.jl as the default lowering implementation. Julia Lowering is intended to improve code provenance in Julia, and which will have a big impact on future developer tooling. And I definitely say, yeah, if you have not seen the JuliaCon talk on the new Lowering, which is Tim Holy and Claire Foster, definitely check this out. Right, Claire is the same person who worked on the I believe she also did the Julia syntax, right?
Yeah.
The new parser, right? And so now that's doing a lowering scheme, and then if you don't know, lowering is like one of those steps in the compiler for how you turn it into the lowered code, right? Um, and really, the key thing about putting it into Julia is it can be faster and it can keep more information. And by keeping more information, we can better tell you where your error messages are, or you give you better error messages. I thought she had in here like a really nice example of what she wanted the error messages to look like. Um, oh, here it is, right? Saying like pointing to a specific part of the source rather than just a line number, being able to say like, oh, hey, look, right in here, there's certain things that can be done, right?
Yeah. Maybe we can talk for a bit about the compilation pipeline. I don't know if you've mentioned this on the podcast already.
I don't think I have.
Can you go
Yeah.
to the Julia documentation in the developer documentation, eval of Julia code? If I knew how to send DMs on Riverside, which is the platform we use for recording, I would send the link in a DM. But
You can send it in the studio chat, but I think I got it here.
yeah, so there it is, eval of Julia code. Yeah, so just to show this one, it's a
Beautiful
nice
diagram. I
pick.
didn't know this diagram was in there.
Yeah.
I just remember like the first version of the diagram that I remember was oh god, the guy who created the Julia stats, John Miles White, before he went to Facebook, right? He had a blog post in 2014 that had the first version of this. Now it's funny to see it in the docs, but weird tangent.
Yeah, so I just wanted to mention this because I guess like most Julia developers, I wasn't familiar with the intimate details of the compilation pipeline, and then I started working on automatic differentiation in Mooncake, and I was forced to learn this. But
Mm-hmm.
so if you're not familiar with what parsing or lowering means, essentially you're starting, and correct me if I'm wrong at any step, right? But you're starting with source code, which is what you write in your editor, which is basically a string, right? It's a big string, which is everything you put into your .jl source files. And then the first step is parsing that string so that you recognize what is an assignment, x equals 1. What is a function call, f of a, b. What is a type definition? What is a module, etc., etc. So you take your string, which is sort of this unstructured blurb of instructions, and provided that it corresponds to valid Julia syntax, you make something out of it that is called an abstract syntax tree. And that tree, why is it a tree? Because at the very top is the first operation you apply. For instance, let's say if I do f of x plus 1, y plus 2, the top level operation is f, a function call, and then I have two leaves of the tree, which are the arguments, x plus 1 and y plus 2, and then each of these leaves in turn splits because each of these leaves is itself a function call of the add function between x and 1 on the one hand and between y and 2 on the other hand. So whenever you parse code, what you're actually building is a representation of your code as a sort of graph which happens to have no cycles, so it's a tree, and it tells you which operations you're going to execute into which order. And then into that graph, you're going to evaluate your macros, which are transformations of abstract syntax tree into different abstract syntax trees. And what we're talking about right now is the lowering, where you essentially take your abstract syntax tree and translate it once again to a more, let's say, compiler friendly representation. So I think I'm not sure exactly which type of representation is used here, but the idea is to make it as easy as possible for the compiler to perform operations like type inference or optimization steps. And that's not easy with an abstract syntax tree. It's easier when you have a program that is represented as a series of instructions. So that's what's
Yeah.
happening here, and that's what Claire is working to improve.
Yeah. Well, I mean, one of the key things is that, for example, at abstract interpreter level, right, you might say like, oh, I have a while loop, right? And inside the while loop, I did this, right? Whereas then when you go down to the IR level, you try to do a lot of canonicalization. You say, well, there's no such thing as while loops. It's just a go-to, right? It's just a go-to on a recursive expression. Like you try to decrease the number of things that actually exist in your world, and so that way you can more easily reason about programs. Um,
Yeah.
and so that's what happens in the IR level, and then SSA IR is where you just say, yeah, everything can only be assigned to one. So if you say x equals 2, and then x equals 3, and then x equals x plus x, right? You just say, okay, that's actually just x1, x2, x3. I'm just going to call them different things, right? So there's like all these different steps that happen before you get to your final assembly code. And the reason here is that the compiler wants to do a lot of reasoning and optimization and such, but what we've had before was that until what was it, Julia 1.11, the source code to AST, this was actually done in FemtoLisp, right? Which FemtoLisp has a very interesting developer, right? It's this guy named Jeff Bezanson who just happened to create a Lisp, right? And if you actually do Julia dash dash Lisp, it actually opens it up, right? So this guy had created this Lisp, and so since he was writing parts of Julia, including all of it, right? He happened to just use his own Lisp as the parser at first, and so it kind of just stayed. And then I
Wait,
believe that
what's
the lower
torture.scm?
hmm?
You just quickly scrolled by a file called
uh,
torture.scm.
we don't talk about torture.scm, not in not
Let's let's throw a veil of secrecy over this.
Yeah,
Yeah,
but I think lowering right now, lowering might. I guess it still is in the scheme. So for FemtoList as well, right? And that's moving to pure Julia.
yeah. And just to conclude, IR is for intermediate representation, and there's
Mm-hmm.
actually more than one. So as you can see, along the pipeline, you go through different types of IR. You have a first one, and then you have the SSA for static single assignment, I think, or single static assignment, which means that every variable is assigned only once. And then you have another dialect, which is the IR used by LLVM. So there's not just one IR to rule them all, even though LLVM is trying actually to do that. But there's various dialects that you use at various types of the compilation pipeline.
Yeah, and then even then it loops around a little bit to do things like, for example, like figuring out whether it should call a function or whether it should inline the function. It loops around and keeps on hitting the same IR over and over and over, running different passes there. Where one of those passes can be running automatic differentiation, right? So
Yes, it's torture.ad.
all right, and then, but then okay, so the key here is let's I didn't want so clean up the lowering API. So it looks like in the last month things are just getting closer. I don't think these things actually landed on master yet though. That
That
the
definitely does look merged.
well this is merged, but I mean like I don't think that master version of Julia is using JuliaLowering.jl yet, right? It's just there's enough in there that you can start experimenting with it, but it's not the thing that is being. Oh, is it? Oh, okay. Allow switching to. Okay, so I guess as of 3 weeks ago, you can now experiment with using it. So yeah, I'm sure though that this is going to take a lot of. I mean, okay, the first is limitations. Compilation's pretty slow to start. These are all things that get worked out, and I'm sure that there will be 50 bugs that are found the moment that you switch over to it. So, not ready to be used yet, but it looks like it's close enough that you can actually test it out. Like you could pull a nightly version of Julia and switch over to using it, if you're so inclined. Well, I guess I forgot to go over to the tab. But yeah. So if you're so inclined, as of 3 weeks ago, you grab a recent master, and now you can just flip a switch, and you are now running with Julia lowering, with all the caveats involved. So pretty cool. Okay, the StyledStrings standard library committed piracy against space. This led to invalidations that had a higher latency. Was deemed untenable, so ongoing fix to fix the piracy and invalidations. I did see some discussions about style strings in grapes channels and such, but I didn't follow this controversy all that much. I don't know if you followed it directly.
No, I didn't. Perhaps briefly, in case our listeners don't really know what type piracy or invalidations are, Type piracy is when someone takes a function that they do not own on types that they do not own and they redefine it. So here, presumably, what StyleString was doing is redefining some version of printing or displaying on types that were also defined in base, probably. And that's an issue because it means that essentially, when modules are precompiled or when code is compiled, they sort of assume that everything that's defined outside of base does not interfere with the behavior of base on types and functions that it owns. And so that's what's called an invalidation, is when you have to recompile a method because you made assumptions about the behavior of base, for instance, and then StyledStrings was loaded and your assumptions went down the drain. So you have to invalidate your compiled methods and recompile them, and that introduces a bit of latency that makes people, angry.
Yeah, and so I think, this is the one that's pointing to some of the controversy around it. And controversy, it's an open source field, so we're just kind of more just patting each other on the back, be like, bro, you made my code slow. But I think that the key thing here was that StyleStrings was brought in, I believe, into the REPL. StyleStrings was brought in so that way we can make it easier to print out different colors for being able to make different parts of the REPL, like easier to modify. Right. The earliest version of the REPL was just using, or earlier version of the REPL was just using ASCII colors, right? So that's why packaged REPL and stuff was blue, but that was kind of, ASCII colors is not the easiest way to do this. So there was a library that was brought into the standard libraries, which is the StyledStrings. And then it caused a lot of latency issues due to certain type piracy, ways that it was working, yada yada. And so then some folks were like, oh, should we have this in here? Should we not have this in here? Because one of the big things with Julia that's being worked on is a lot of the latency, right? And so, yeah, I think that there was some discussion about should we keep it in, should we pull it back out, and I don't remember what the final solution ended up being on this, but there was a lot of work to make sure that it would not be at that huge of a latency issue. So at least the latency issues are worked out. I forget whether the solution was just to remove StyleStrings or whether each of the cases were worked out enough, but. Yeah. So, but I mean, this shows you that there is a whole patrol that's trying to make sure that your latency does not increase in future versions.
Yeah, and there's other items on the newsletter that go back to this.
So the discussion on optional module. Oh, did you have another thing that you're going to bring up?
No. It's just basically all of the newsletter is about latency today.
Well, then let's get right to it. Let's get it, because we have latency getting there. Okay. The discussion on optional modules has bubbled up again. Ooh, I think that this might be referring to
one of those is yours.
Yeah. Oh, this is a fantastic one. Yeah. So okay. Yeah, it's definitely has bubbled up again because I mean the real question comes up with I mean if you haven't seen Ordinary DiffyQ, it's a lovely repository, right? So each of these are separate packages. Inside of here, but then one of the things that can happen, for example, if you have a package that has all these different modules, is, for example, sometimes you might want to change something in the core library, and it might be not a breaking change, right? Because you're like, oh, this is not public API, but all of my solvers use this, right? And so what do you want to do? Well, you don't really want to do a breaking change because everyone else has to update. You know exactly the list of packages that are using the non-public API. You just want to bump all these package versions at the same time, right? So some people started throwing around the idea that maybe the right way to be able to do this is every single time we do a release of anything Ordinary DiffyQ, we just always bump all the packages and we just make it so that way all of them are equality version between each other in this list, right? So we would just do, instead of one release of a package, we'd now do 30 or 40 releases each time. Some folks did not like the idea of what that would do to our package registry. There's a lot of discussion about what we could do instead. But that's really the key, right? Because I think that the key question that's going on here, I mean, you could read this, and it's a pretty long thread that goes in a lot of detail, right? But the key question is that, again, it's about latency. Right. In Julia, we now are splitting apart our libraries to be able to have less latency, right? So the reason for having this split is because, you don't want to load this algorithms all the time and this algorithms all the time because it adds latency to your approach. But they actually are the same package in a sense, right? Like I want to, as a developer, be able to just give you one package version, and I want to just so that way, I'm using, you don't have to keep track of 30 package versions. Like you want to know what version of package you're using. You don't want it to be 30 different numbers. And also, I just want to just be able to work between these. I don't want to have these barriers that are considered public and all this, right? But I don't want to load the entire piece of code all the time because ordinary DFQ is almost a million lines of code at this point, right? So you split it apart for latency reasons, but how do you make it act together? Is then the question. And so there's a lot of different discussions going on. The lines of, okay, what does it mean to be a sub package, right? Can you have sub packages that are, what's the difference between a sub package and an extension, and all this discussion?
Yeah, and it's definitely far from settled. Like I don't think at the moment there's a good solution to specifically to ordinary diffq because it's a problem in other packages, but the SciML ecosystem is sort of the worst offender when it comes to having lots of different packages that must evolve in sync.
Yeah. Oh, definitely. I mean, again, because they're not. If there was no latency issue, I would not have make them different packages, right? The only reason why they're in different packages is only because I want to control how they're loaded, not because that's how the best way to divide them, right? And so, yeah, there's a lot of discussion we had of, what is a subpackage? Should they each have their own project.toml? Should they each have their own version? Would they be allowed to have different dependencies? Or do we get that, there's all these different questions that then have to be answered. But the core developers kind of know that there's a problem going on here, right? And SciML definitely hits this in ordinary DFQ, nonlinear solve, and all these things. But also, for example, CUDA is another place that has this, right? CUDA.jl has, 6 different subpackages for QSolver and all these things. And they're version locked, right? And right now that's all done manually. Like, the version of QSolver changes every single time you update CUDA.jl. You need to make sure that they are exactly the right version, and they version lock it by hand, right? So the question of, should we just version lock things in CI, or is this actually a Julia feature we should have, right? So lots going on here. Yeah. And then the next one is there have been many posts about the increasing load latency of the Julia since 1.10. This issue is well known, and the compiler team is looking into it.
The first link, I don't know if you saw it. It's the discourse post by Fons.
Yeah, I've seen the Fonz one. I don't know why it doesn't say it has any clicks. It must just be clicks directly here, right? I guess everyone who reads the newsletter has already read Fonz's.
Maybe.
But yeah, Fonz definitely put a nice graph here that really illustrates that, 1.10 is a very good LTS, right? Like, I think that's one thing to point out. Can you share
that tab, maybe?
Oh, oops. Haha.
Yeah.
1.10 is a very good LTS, right? Like, for a long-term support version, it's a pretty good version, right? But we definitely have had some load regressions since then, and 1.12 is showing some more load. But again, 1.12 is not quite out yet, so don't take that as the final answer there. But yeah, it's definitely regressing a bit. And so there's a discussion of how do we make sure that we keep things, loading fast.
Yeah, and if you want to play around, there's a notebook link here where you can actually go and toggle or untoggle the various packages. So it's actually really nicely done as usual when Fons does anything, and you can play with like the 1,000 most downloaded packages or most starred or whatever in Julia, and figure out for every version which one you want to measure and whether you're measuring load time or compilation time. So it's really neat, and of course it's all Pluto based.
Yeah, that's pretty cool.
And the other thing that's interesting is Timothy came up, I think it's Timothy, right? Tikozor.
Mm-hmm.
Timothy came up with a website where you can actually submit minimal code samples, snippets. This is on the newsletter again, where you can actually submit code snippets for the packages that you maintain or that you're aware of, where you can say, okay, this is sort of the minimal workflow that you can do with my package. And it's really neat, actually. It allows you to, it automatically measures everything in GitHub CI, and it keeps track of the dependencies. And actually, we could do one right now. It takes like 1 minute. So if you go to his repo, I scroll further up. Yeah, just here, TTFX snippets. So just to show users, because it's really easy, create a new issue. So primary package, which package do we want to test? Ideally something simple, not like, okay, if you want. Small q. no .jl. Okay, task name. So what do we want to try?
Solve the lens equation.
Okay. Other dependencies that we need?
Let me just pull up the README here. I'm just doing the README example.
Come on, you can't blurt out the README example of ODE by heart.
Well, I was trying to see like, do I have anything else in there? I don't need to have plots in there.
No,
Yeah.
no, no.
So no.
No, because we actually want to measure this and not plots separately.
Yeah, yeah. And then attributions.
So, documentation of ODE, README of ordinary diffq. Okay, and then copy paste.
Is
Yeah,
that it?
I think that's it. The using statements should be at the start, but that's the case. And then it will open a PR for you, and it will run your code and measure it and store it. And we'll see. We'll go back to this at the end of the newsletter.
That's cool. Yeah, I didn't actually see that part. Okay, cool. Yeah, let's one of our viewers should give us a reminder to check it out.
Yeah, the live viewers, of course.
Yes, the live audience. My cats are over sitting there somewhere. So, okay, but yeah, let's just remember. So okay, detailed new documentation on the world age mechanism in Julia. Oh, I did not know that there was a new documentation on this. Okay, yeah. I mean, I think a lot of this kind of comes from, if you haven't seen the paper that Jan Vitek did with Jan Vitek's lab did with Jameson. That is a very good write up on World Age in Julia. Um, it was a paper that was put out in 2020, right? So Jan Vitek with Ben Chung and Jameson Nash and Julia, right? They wrote up a complete description of how World Age works, why it's there, and all this. It's a very fundamental part of how the Julia compiler works. And so if you're curious about details about like, well, how does Julia get its performance? How do you make sure that it updates things correctly? What is invalidations all about? Right. This is actually a very good description of that whole bit. And my understanding here is then they took a simplified description of this for humans, and then they've now put this into the documentation in some form.
Yeah, I just read it. It's really nice. Essentially, the world age is sort of the counter that tells you where you are in terms of which methods have been defined or which symbols, etc., etc.
Mm-hmm.
And it's very rarely you run into world age conflicts, but most users should not have to care about that anyway.
Unless you do things with symbolics and modeling toolkit.
Yeah, or you use eval at some point in your code to generate new code. Essentially, this is only
Yeah.
needed because Julia can at runtime generate and execute code. If all you could do was use the code that exists, you probably wouldn't need that.
Yeah. So when you're trying to do staged compilation, right? So if you're trying to do something in Julia and then at runtime you're trying to invoke the compiler, then call the compiled code. That's when things kind of start to happen, where you'll see. I mean, it gives you a pretty explicit error that says a world age issue is occurred. You're trying to call a function that exists in the world age. Call invoke latest instead. And then yeah, it gives you exactly this error right here, right? So and the main thing is you should either invoke latest or you can use the real trick, which is
Restarting the REPL.
runtime generated functions.jl, which there is a library that kind of but it has, of course, pros and cons. So there's certain things with this, but I mean, you can read up all about why this stuff exists, what these things are doing, and what world age is in this new documentation. So okay, that's cool. Further progress and support for LLVM v20 is near. Yeah, since Valentin is no longer in the Julia lab, I don't get periodic updates on what you're actually getting with each new LLVM. So actually, I'm not sure what the LLVM 20 is buying us in this round. I don't know if you dug into this.
No.
Maybe we'll get one of the compiler developers like Gabriel or something to leave a comment on the YouTube, which all of you should do as well, to basically tell us like, hey, is this version bump for LLVM 12 or 20? What are we actually getting from it? But we always periodically do these version bumps. Different versions of Julia have different LLVM versions that they're tied to, and so I assume that this would be not targeting 1.12 because that's already in beta phase, right? But instead 1.13. Alrighty. Unexpectedly, a few optimized methods of base have been found slower than the naive implementations, providing rare opportunities to optimize code simply by deleting stuff. Does this include the matrix multiplication that is doing a bunch of batching in a non-fun way?
No, I
Okay.
think I remember this. I think it was Matt. Um,
Speed up rand perm by just using rand. Oh, that's cool.
yeah, I remember another one where there was a series of Slack messages by Matt Bowman who essentially was pissed at the performance of custom map reduce dispatches for like maximum or extrema or things like that. Yeah,
Yeah, I
exactly.
think that this
So
one right here. Yep.
So there, essentially, Julia has a few optimized code paths, which we thought would be faster for computing maximas and minimas of arrays, and it turns out they're not actually faster, apparently. But there was a community benchmarking effort to get that running on as many platforms as possible, and to say, okay, on this platform it's faster, it's smaller. Yeah.
Optimization.
Well, an optimization is only an optimization if it's actually optimized. If not, it's just a hindrance.
Hmm.
So yeah, you see that this is the community banding together and saying, okay, I have an old Tamagotchi in my drawer. Can we run benchmark Extrema on it and figure out if it's faster? Yeah, it was not.
Yeah, well, and I guess, and then this gets added to automatically to Nano Soldier as the new benchmark test, or
I don't know. I don't know if the benchmark was actually inserted. I just know that the code was changed, the source code.
yeah, because I don't see this in Nano Soldier, so you should comment and say, hey, look, let's add this to the benchmarks, right? Um,
Yeah, but we
yeah,
should have
okay.
an anonymous account like a Julia Dispatch Anonymous for these kinds of comments during episodes, so that people won't know who it is.
Yeah, but then no. I remember I had a few videos back on the Julie Ling channel before where I was just like, oh, then you register example package and then you just go over here and you close it, right? And then within like a month there was like 300 people that tried to register example package.jl.
Yeah.
So I know to be I know not to post anything on while doing the video now. Um, but
Yeah,
okay, it looks like there's
you're
even
kind
more.
of specializing in disrupting the general registry.
Oh, yeah. I mean, do you remember Cuddle.jl? I definitely broke the general registry CI at one point by making a package that depended on all other packages that existed. It's a giant cuddle party.
Yeah, I do remember that one.
Yeah. So it looks like okay. So Matt Bauman definitely did the Lord's work here by deleting code. That's funny. I didn't know that this had occurred. Alrighty. A talk for non-Julian audiences on the recent progress on static compilation at PyData Global. Right. So I mean, we did have Jeff on
Hi,
here
everyone.
to talk about everything that was going on with Julia C. So it's not complete news to everyone watching this, but if you want to watch the latest version of Jeff's talk, where he goes into making small binaries, um, well, there you go. He has a it's now getting pretty it's got memes and everything now, right? So he's got it really refined.
Yeah, there was a few of us at PyData, facing obscurantism, and no, actually, it was really nice. It was a nice conference, and the Python folks were curious about Julia, and the Julia folks were curious about Python. So I strongly encourage people who have a PyData happening in their town to just check it out. And by the way, we made it so that JuliaCon Paris happens right after PyData Paris. So if people want to kill two stones with one bird, they can attend both in 1 week.
Feed two birds with one seed.
Yeah, something like that.
All right, and then why are static arrays immutable? Discussion. Okay, yeah, okay, this is just going to be a discussion on static allocations, stack allocations versus heap allocations and whatnot. Yeah, I mean,
Yeah.
if folks haven't dug into this aspect, it definitely is something to learn about Julia for understanding Julia well, understanding performance well and such. The difference between static and heap allocation. So definitely take a look at this thread. I think that Oscar definitely did do a pretty good write up here,
Yeah.
with also Mason involved as well. Yeah.
Essentially, the gist is that if you're ever working with small arrays of size, roughly speaking, smaller than 100, you should check out staticarrays.jl. And this
Yes,
is
that's what
especially true if you're working in, physics simulations where your arrays are mostly 2 or 3 dimensional. And that's you don't want to work with a tuple because with tuples there are some nice operations that you can do, like summing or linear algebra. But as soon as you go over to static arrays, you can do all of this stuff even when your vector is size 2 or 3, and the speed ups are immense compared to normal vectors. So do definitely check it out.
Yeah, and I think that the key is that when Julia says, "Oh, your code is slow because you allocated," right? It's missing a thing that says, "Oh, it's slow because it did a heap allocation," right? And stack allocations are not counted in that for because they're so much faster. And so if you use something like staticarrays.jl, you can allocate static arrays all the time, and it won't be counted as allocations. It won't slow your code down because they work a bit differently. And this thread goes into a lot of details about that. Ecosystem for maintenance and collab promises. Oh, collab promises. Okay. I guess
I guess
Google's
that's not
taking
Google
over.
Colab. Yeah.
TestPicker.jl, a nice tool for interactively running a subset of tests, matching a fuzzy search. Oh, interesting. This one I had not heard.
Let's
Theo
see.
does a lot of, what is it, Turing.jl?
Yeah. Probabilistic programming.
Maybe I can make this a bit bigger. No, it's a bit hard to make it bigger.
We get into test mode by pressing the exclamation point. From there, we can access all test fuels, files, and can filter them. Okay. Let's see. Okay, so it seems that you're basically in the test environment, and you enter the name of a test file or a subfolder, and then you are taken to a sort of interactive REPL where you can select which tests to run. I think it's kind of a riff in the REPL on VS Code's test items framework, more or
Yeah,
less.
yeah. It looks like it's VS Code's kind of test item stuff, but now moved to the REPL. I
Yeah.
think I see more and more things actually adopting the test items around the ecosystem, and so I kind of think that relying on test items and more tooling built on test items, I think is where things are going to go. It's actually interesting to see this using test sets directly rather than test items. Um,
Yeah. Essentially, for those who don't know, test items is a sort of it's a pure Julia thing that you can use independently, but it's really well integrated into VS Code to allow you to run only a subset of tests in your package at once. And that's really useful because it keeps the test environment running. You don't have to reopen it, activate it, precompile it. And I've heard that for test-driven development, where you write a few lines of code and then you retest, it's really useful. I haven't made the jump myself, but I plan to at some point.
Yeah, I think I have two libraries using it out of like 190 or something. So, starting. But yeah, I mean, there's other frameworks I think like TestIt.jl and such, which are now just assuming that you've written everything using test items, and then they will parallelize your tests and things like that. So it's kind of like a whole. It's kind of started as just like, oh, this is for VS Code, but now it's kind of starting to be its own part of the ecosystem there as like a foundation. Say, yeah, if you have test items, we can do X, Y, Z on top of it.
I think the main thing that's blocking me at the moment is that the main package I'm responsible for is differentiation interface. And it just so happens that I cannot instantiate one test environment because I want to instantiate each differentiation backend into a separate environment so that their compat bounds don't, interact in a nasty way. And so that means I essentially need 15 test environments,
Yeah, yeah,
which is not a
that's
common use.
understood. I mean, automatic differentiation libraries, things that go over all the automatic differentiation libraries will have definitely dependency issues.
Yep.
So yeah, BorrowChecker.jl, a runtime borrow checker that can be disabled in release code but kept enabled to detect bugs and structural issues in your library code. Yeah, so this there's a long discussion about what it's for and such. I think its main use case is for making sure that you limit or just remove the ability to have
Race
accidental
conditions.
race conditions in multi-threaded code. Yeah.
Yeah, that's
Um,
one of the main motivations behind Rust's memory safety features.
mhm.
So essentially, this is an adaptation of a mechanism that exists in the Rust programming language, where objects that are defined in a specific function or assigned to a specific variable cannot just be passed around by reference without, um, essentially punishment.
Yeah.
So it prevents you from doing silly things by default, and if you want to pass around something, you have to explicitly be aware that you're doing it, which reduces, I guess, the number of accidental errors, especially in multi-threaded code where accesses to the same data structure may not be performed in the right order. So yeah, that's the gist, and it's done by, I think, Miles, so it's, as usual, very high quality.
Yeah, so there's a lot of interesting stuff there. There's pros and cons because Rust is using it for something that's not a GC language, or GC languages are a bit different. So I don't think it's necessarily the final say in this space, but if you do want to use something today that is similar to Rust BorrowChecker, it is a pretty functional thing that you can just pull up and use. So it is nice that exists. Pluto Notebook is getting AI coding assistance features. Sweet, so you can vibe code more. They're taking a very cautious approach of only putting a limited scope at a high value right now, like e.g., automatically fixing syntax errors.
Yeah, so it doesn't fix your code unless there's a syntax error, basically.
So there's just a fix with AI button. Oh, so that's what all these emails going to my inbox. It says, "You are fixed with AI. Please respond to this in 10 seconds."
Yeah. I don't know. I think it's nice. I'm generally not a fan of LLM based coding, but I think the careful approach is a nice one,
Yeah, yeah.
especially for beginners because you want to smooth out the hurdles to getting the first cells running.
Mm-hmm. I think Fonts really has a really good eye for how do you take things that are deep and new and turn that into the right user interface in a way that is will actually teach you and you actually learn something from it, right? And I think that this is a really this really encapsulates that. Yeah, a lot of people are just going to say, "Oh, AI will give me something useful," but this is something where yeah, if you have a syntax error, this will show you before or after in a very simple way. You'll learn how to do this, and maybe you don't need the AI in the future, right?
Yeah.
Um, cool. I like to see what Pluto's going to be doing next as well. So AskAI.jl. Oh man, there's just a lot of this. LLMs are everywhere. All right, direct AI support in REPL. Oh, so you just use a add AI. So Guillaume,
Yes.
now that this exists, I wish it wasn't past April Fool's Day because there's a package I've been wanting to create. Maybe you're the one that I want to create this with. I want to call it it's a new automatic differentiation package where what you do is you send your code to an AI and you ask it what the derivative is and you just take whatever it gives you. Um,
I think it exists. Wait.
okay,
Yeah, but I think it's already been done. Yeah. It's called TextGrad. Google it. TextGrad automatic differentiation via text.
all right. Dang, it beat us to it.
Or maybe it's no, maybe it's not exactly what I think it is. Backpropagation through text feedback. No, that's not exactly the same thing. No, okay,
Yeah,
my bad.
this is not the same thing. All right, cool. So we still got a novel idea here.
Yeah, it's gonna be epic. Half of the
Yeah,
time it won't compile.
but who cares? I mean, yeah, and sometimes they'll just tell you the gradient is zero, but it's AI, so it
Like
must be doing something.
symbolics.hessian, right?
Okay, fixed that yesterday. But yeah. What's it? But yeah. I do want to see what happens if you just start asking ChatGPT, like, hey, here's my Julia code. Just give me a function that computes the gradient of this code, right? And let's just see what it comes up with. Okay,
So
cool.
RxEnfer is a library for probabilistic modeling. So it's a slightly different take than Turing's, where you, from what I understand, you're working with factor graphs more or less explicitly. So it's more in the, I would say, traditional graph-based modeling syntax rather than something more generic like probabilistic programming.
I don't think that's necessarily the case. I mean, you give it code and it basically uses a compiler to do the type of algorithm, right? I mean, what the algorithm is effectively doing is it's representing all of its variables um, as what's the word,
A
as
factor
random
graph.
variables. Yeah, well, factor graph of random variables, and it's almost doing a form of like automatic differentiation, where instead of pushing through, derivatives, it's pushing through the properties that are representing these random variables. Um,
Yeah, no, that's the sort of the paradigm behind every probabilistic programming framework. But what I meant to say is that, for instance, Turing is mostly focused on Markov chain Monte Carlo algorithms,
yeah, yeah.
and here the the main paradigm is called message passing. And message passing is actually a form of variational inference. So, very roughly speaking, there's two ways to perform inference and make parameter estimations and things like that on very sophisticated probabilistic models. One is to simulate, so that's the Markov chain Monte Carlo approach, where you essentially run a bunch of samples and you evaluate them according to their likelihood. And the other one is what's taken here, and it's also done a little bit in Turing, but slightly differently. And here is essentially approximating the distribution with a parametric family. So just like in machine learning, where you use neural networks to approximate functions, here in variational inference, you use parametric families of distributions to approximate complex distributions that you don't know. And the gist here is that the parametric families are defined by a graph which models the dependencies very explicitly between random variables. And that's perhaps something. It's also done in Turing, right? Because of course it has to know the dependencies, but perhaps the graph aspect is not stressed as much. Although I'm not an expert in either of these packages, so I wouldn't be sure.
Yeah, I've been talking with the devs a little bit about this. I'm probably going to head over to Eindhoven sometime to chat with them, hopefully soon. They actually just said that I'm welcome. I need to respond to this. Yeah, I mean, I think the key is, I mean, because of course, what I was trying to do is I was trying to stick differential equations in there.
As you do.
But I think the key is that yeah, you can do this over normal Julia code, right? Because like compiler IR is like a representation for graphs effectively, right? And so you can use the Julia code as the graph representation. But then there's certain things that are easier to do with automatic differentiation, like for example, arbitrary control flow that is recursive and stuff. That might be very difficult to do with some other representations, right? Making sure that you don't have a recursive graph might be a requirement of this, right? So there are different limitations and such, but you can actually use it with something that is fairly, just general Julia code. There's some limitations on control flow though.
Yeah. Essentially, you want a finite graph, probably.
Yeah, but then I think with this, they're making it so that way you can more easily use this through HTTP servers and such. I'm
And
not
from
totally sure.
Python.
And from Python, yeah. Yeah, I think that the main use case was to be able to release a Python version, but it is interesting that it's all set up through HTTP types of requests. Cool stuff going on there. Zero-dimensional arrays. What is a zero-dimensional array?
It's like a ref, but apparently it's better. Not sure what this is, to be honest.
And the first response is question mark. All right. Well, I guess we can battle it out in the comments. Why do you need a zero-dimensional array?
Yeah. And choose the name.
Alrighty, that one I know quite. Okay. Possum tracker for target tracking in videos. Okay. This is using a ML type of approach, I assume. Right.
Probably, yeah.
I remember when it all used to be PDEs. It's sad where we've gone. Structural vibration.jl. I believe this was a MTK based. Yeah, so there's new modeling packages being put out. I think we're getting to the bottom here. Click trees, small collections. Oh, small collections.jl. I believe. Yeah, this is for making it so that way you can have small collection, small variables that are not reallocating all the time, even if they're mutable, because they could have their own kind of global cache and stuff that they're pulling from. So I think this is
Yeah,
a
and
very
I think
cool idea.
it's also about like tuples, more or less tuples of variable length or things like that.
Mm-hmm. Yeah, so small, mutable small vector, right, gets pretty close to being a static vector, but it because of the way that's doing this recaching and stuff. So very nice set of tools that are coming out in terms of more performance.
And just click trees, you might have discarded it, but it might actually end up being useful in sparse autodiff.
Oh, really?
So there's a way to use it inside sparse matrix colorings.jl. The author of the package submitted a PR. It's on at the surface level, it's a very abstract decomposition framework for graphs where you essentially split them into cliques, and the cliques are linked together by trees. The clique in a graph is a subset of the graph where every vertex is connected to everyone else. So everyone knows each other. That's why it's a clique. And the clique tree is a way to split a graph into a series of cliques, and it's very useful in probabilistic inference, precisely with the kind of models that Eric's Infer works with, because you often want to perform inference on hidden variables in the graph, and for that you need to do what's called marginalization. You need to sort of sum out the variables that you know about or that you don't know about, and the order in which you do that is not easy at all to figure out. And so the clique tree algorithms are algorithms that are linked to this notion of in which order do I contract a tensor network, in which order do I marginalize variables in probabilistic inference, and it turns out also in which order do I color nodes in a graph to have the smallest coloring for my sparse matrix. So for instance, this gives you the optimal coloring for a banded matrix, but it's also part of a more general framework which works on other types of graphs, every chordal graph essentially.
Okay. Yeah, I mean, I know that I was asking a bit earlier about the analytical solutions of certain structured matrices, and it sounds like click graphs gives you the banded matrix one right off the bat. Or
No, but I'm actually curious about that one. We'll discuss it again
Mhm,
offline.
mhm. Yeah, I guess another application for this would then be fast multipole algorithms and things that have to do like in molecular dynamics when you're trying to find out distance calculations, but you only want to do distance calculations between things that are close. That would definitely be another case where you'd want to only look at nearby cliques. So yeah, that's cool. I need to look into how they get it so fast or what the specialty in this algorithm is. All right, leadgroups.jl. A lot of stuff with the manifolds.jl is definitely improving more and more. And I think that they have lead group integrators. So if I know that some folks have been asking about ODE solvers over lead groups, and I think the ones that are specialized with the lead group packages are this is definitely something I find to be pretty interesting. It's pretty useful for folks that are specifically doing some well in non-Euclidean solving a non-Euclidean manifold, such as solving nonlinear systems and optimization problems on manifolds. So definitely the Julia manifolds folks have a whole lot of stuff in there that if you haven't checked it out yet, it's pretty deep.
Yeah, and go watch Ronnie's talks. He's usually a good presenter.
Mhm. Convolution interpolations, smooth high dimensional high order high accuracy interpolation. Ooh,
Oh, could this be the new ND interpolations?
using separable convolution kernels. Okay. Yeah, I mean, there's just so many different ways to interpolate that it's always useful to have more.
Yeah,
Um,
there should be a package that interpolates between all interpolation packages.
I think that's what we're gonna try to do with the ND interpolations, because they want to put them all in one interface, where setting each one of them up with symbolics and da da da. It tends to be a pain to get compatibility with symbolics and automatic differentiation and all the things you have to do. But
Oh, really? Are you telling me that it's a bummer to put all into one interface because it's a lot of work? Yeah, I
yeah,
guess.
yeah. If only people could solve that problem.
Breakers. Binning continuous data.
This one I don't know actually too much about.
No,
Um,
me neither.
Numerical distributions.jl. Yeah, so numerical. I knew that this one was not published for a while, but I guess now it got published. Basically, if you want to supply your own PDF and still you want to use the distributions.jl API, you can just give it your function and you say, okay, here's also the integral. So here's how to compute the integral, so you get the CDF, and then you
Yeah,
could
perhaps
use.
for a bit of context, PDF is probability density function. So a
Mhm.
distribution on a continuous domain it does not put load on any individual point, but instead it gives you a sort of density function so that if you integrate it over an interval AB, it tells you the probability of sampling a point inside that interval. And so when working with these distributions, for some cases, we have functions which have explicit integrals or very easy to calculate, like the uniform distribution has an easy integral, and the normal distribution has no explicit form, but it's so well known that it's very fast. But for more sophisticated density functions, essentially you have no choice but to integrate it numerically. So that's what this package is doing, I guess.
Yep. Yeah, well, what it lets you do is if you have code that's set up to use, distributions.jl and it just doesn't have the distribution that you're thinking of, right? You can define your distribution by giving it, you give it a PDF function and tell it how to make the CDF, and boom, then you have something that matches the interface. So it's
Yeah.
pretty useful, I think, for a lot of. Well, I think a lot of times you like get a distribution out from what's the word, from like Turing and stuff, right? The Bayesian inference packages. You could just turn those into distributions, and now you can use those as a random variable, which is pretty
Yeah.
cool. And then numerical linear algebra class at Julia at TIM. Yeah, I think I looked over these notes before, and they're pretty in depth. Yeah, so it's pretty cool to go through. If you want to look into like multi-grid methods and see how they're all implemented in pure Julia, you can go deep into the numerical linear algebra stuff. And then Stefan was saying last time that we're still open for people to register to the Q numerics. I believe this is out in Amherst. Yeah. So just northern Massachusetts. So if you want to work on numerical methods in quantum information science, if you want to do a summer school in that, for graduate students and stuff. There's also going to be ODE solving stuff there, so I'm going to see if I can make it. But GPU computing, symbolic computing, right? Because they do symbolic quantum algebras and such. There's a lot of cool stuff that'll be going on here related to the idea of quantum information science, but some of it's more core utilities and how it relates to it, growing the community that's interested in this area. If you're interested, register for this. There's going to be a summer school going on just before JuliaCon. And
Just before the first JuliaCon of the year. But don't forget, there will be 2 this year.
Mm-hmm. Oh, yeah. So I think that's it. Do you think that there's anything else that you wanted to mention from this list? I think that we went through all of them except for what's going on with the Lean 4 and Rust getting a version of kernel abstractions.
Which, to be honest, we don't know anything about, do we?
Never. What's Rust?
Exactly. There was a funny. I thought about it when you showed Hacker News. There was a funny discussion around our latest blog post with Adrien and Alexis on sparse automatic differentiation. We published a blog post at ICLR, which is a machine learning conference, and someone posted it on Hacker News. And there was a person asking which school of thought do these people belong to? And someone answered, well, they're doing automatic differentiation in Julia, which is as close to a school of thought as it gets for this kind of work. So I guess the Hacker News people believe that autodiff in Julia is a philosophical tradition in its own right.
If it is, then I think that we've done well. I'm looking for. I tried to see if I could find it, but I'm not finding that. But I did see you post it before, and I did look into that. It was pretty funny. Yeah, I'm not finding it right away.
Yeah, it's fine. It's called if you Google an illustrated guide to automatic differentiation, an illustrated guide to sparse automatic differentiation, and then go on Hacker News.
So this was one of the popular posts of the month, and
yeah, see here, this paper is written by 3 Europeans. Is this type of analysis a part of a particular mathematical heritage? And then somewhere below, someone answers, the blog post mentions that the authors are all developers of the automatic sparse differentiation ecosystem in Julia, which might be the closest thing to an intellectual school that this kind of work is associated with, which I thought was very nice.
Yeah, now I think that we need to have like old school, placard or something, like old school little pictures of us looking to the side or something. So that way you could have some like some of that old European pizzazz to it.
Exactly. All right, I think we've made it for today.
I think we've made it. Cheers.
Yeah, thanks, and see you next month.
See you next month. Take care, everyone.